So now let's learn about the packing fraction. So what is the formula for packing fraction? So it is nothing but volume occupied by volume available. So the first one which we will be finding will be for BCC, body centered. Okay. So as you know, let's first draw a cube. So how many particles are there? All the 8. All the 8. Along with the 8, there is the body centered atom. So we'll draw it like this. Okay. Now let's put a diagonal such that the first atom from the front and from the back will meet along with the body centered atom. Okay. So now let's find out the number of atoms present. As I have already told, n, which is 1 by 8 into 8, contribution of the corner spheres, will be 1 plus center. Okay, 1. 1 plus 1 will be 2. So n is 2. Now let's find r. So consider this diagonal. Okay, so let this be the center, and this body centered atom, I'm going to draw it like this. Okay, and this, the corner, the first one, let's name it as A, and let this be as B. So the first one, it will be like this, right? So now let's find, this is 1R. This and this will be 2R. And this will be 1R. Okay. So this will be 4R. 1 plus 2, 3. 3 plus 1, 4. Okay. So this is 4R. Now the formula for diagonal will always be root 3 into side. So let's take side as A. Now let's find R. It is nothing but root 3A by 4. Now coming to the packing fraction. So volume occupied. So how many number of atoms are there? There are 2 into volume of the sphere. 4 by 3 pi r cube by the volume available of a cube, a cube, right? Which is nothing but, when you replace r, you get it as 8 pi by 3 a cube, 3 root 3 a cube by 64. This is nothing but r cube. The one inside the bracket is nothing but the r cube. And now, if you do the cancellation, the answer which you will arrive at is root 3 pi by 8. Okay, root 3 pi by 8. So the packing fraction of BCC will be root 3 pi by 8. Similarly, packing fraction for FCC will be, I'll draw the cube again. Now I'm going to put the atoms. atoms in the corner is done. Now we are going to put it to the faces. 1, 2, 3, 4, 5 and 6. So this one will be in the front and this one will be behind. Now the number of atoms here will be 1 by 8 into 8 plus 1 by 2 into 6, which is 1 plus 3, 4. N will be equals to 4. Okay. Now here for R, let's take the diagonal here. Okay, this is just 2D where you just get A, B. Okay. This will be A, this will be B, and this is the front face. Okay, the atom which will be in the face of this cube which is in the front. Okay, now let's calculate the R. This will be like this, A will be like this, and B will be like this. Okay, so this is R, 2R, and this one will be R, which will be 4R. And according to the Pythagoras theorem, for this diagonal, you will get root 2A. Okay. Now here R, you can replace it as R is equal to root 2A by 4, which can be further simplified as root 2A by 2 into root 2 into root 2. So you can cancel these. What will you get? A by 2 root 2. So now we find the PF, which is nothing but the packing fraction, which will be 4, as the number of atoms will be 4 into 4 by 3 pi r cube, volume of the sphere by the volume of the cube. So when you replace the digits values, 6 pi by 3a cube into a by 2 root 2, the whole cube. Okay, you replace this r here, and further when you simplify this, you get the packing fraction of FCC. Next, coming to the primitive cell. Okay, simple cubic cell. Here it's nothing but the 8 corners, right? It's nothing but the 8 corners. So the particles, as I have told before, will be 1 by 8 into 8, which is nothing but 1, right? N will be equals to 1. Okay, now R, let's take this straight line. Okay, here there is A particle, here there is B particle. So how does this stay? Like this. Okay, so this will be R, this will be R. So this will be 2R is equal to, what is this whole? One side is A. 2R is equal to A. So R will be A by 2. Okay. So now the packing fraction for this will be 1 as the number of particle into 4 by 3 pi r cube by a cube. Okay, so when you simplify this, you get the packing fraction of simple cubic cell. Okay, so next coming to the end-centered. So how is this? Again, we draw the cube. Okay, and this at this one end we will be having an atom again here. Okay, so this will be, and here will be 1 by 8 into 8 plus, how is it? So 1 by 8 into 8 plus the contribution, okay, 2 are the ends, 2 into half, okay, so together it will be 2. Next, let's take this, okay, now here we can get R, 2R, R. Okay, so here it will be 4R, which is equal to A. One side is equal to A. Now R is equal to A by 4. Okay, so now the packing fraction will be 2 into 4 by 3 pi R cube by A cube. And if you further simplify it, you get the packing fraction of n centered. I hope I have made clear with the topics.